Hi, I'm Michael Pfeiffer from Industrial Metallurgists. This is the first of two videos on steel hydrogen embrittlement. In this video, I discuss the mechanism of hydrogen embrittlement, and in the next video, I discuss how to prevent hydrogen embrittlement from occurring. Hydrogen embrittlement is of concern for high-strength steels that are exposed to hydrogen, but the most common application of concern is with fasteners, because fasteners are used in so many different applications, and so many fasteners are high-strength steel, which could potentially be susceptible to hydrogen embrittlement. And the concern with hydrogen embrittlement is that it reduces a material's ductility and also renders it susceptible to cracking at stresses less than the metal's yield strength during use. And this would result in poor reliability of products, of structures, and equipment, which is what we don't want to have happen. We don't want to have parts failing during use. So in this slide, I explain about how hydrogen embrittlement occurs. So when a metal is exposed to hydrogen atoms, that metal can absorb the hydrogen atoms, and those atoms will diffuse into the metal. And if given enough time, the atoms can diffuse to the grain boundaries and then form bubbles at the grain boundaries. When this occurs, the grain boundaries become weakened because of the stresses that the hydrogen gas exerts on the grain boundaries, and this enables easy formation of cracks along the grain boundaries because of the weakened grain boundaries. There are a few different sources of hydrogen from where a metal can pick up hydrogen. This is during electroplating, such as electroplating copper or nickel or zinc onto steel, and other metals too. Other metals also can become embrittled by hydrogen. I'll focus on just steels for this video. Also, steels can absorb hydrogen during corrosion reactions, and can also pick up hydrogen from environments that contain hydrogen during use, such as environments that contain hydrogen sulfide. As a result of steel picking up hydrogen, steel will have a loss of ductility, and there can also be cracking and failure when the metal is exposed to stresses that are below the metal's yield strength. These images show two different fasteners that fractured during use due to hydrogen embrittlement. The cracking mechanism with hydrogen embrittlement is called intergranular cracking, and this is when the cracks form and grow along the grain boundaries. This is able to happen because the grain boundaries are weakened by the presence of the hydrogen at the grain boundaries. The image on the right is a scanning electron microscope image of the fracture surface of a metal that failed due to hydrogen embrittlement, and we can see the individual grains very clearly here. The next video, which you can watch, is on prevention, and it is available on YouTube. So go ahead and watch that video. And finally, there's ways to learn more about hydrogen embrittlement and other aspects of metallurgy. First of all, hopefully you'll like this video, and you'll be willing to subscribe to our YouTube channel to learn about other videos that are being released. Also, you can go through all of the different videos that are available in our library that are about various aspects of metallurgy and how metals can be engineered to improve performance and reliability and cost. Also, we offer metallurgy courses. These courses are geared to design, manufacturing, and quality engineers, and they cover many different aspects of metallurgy, also failure analysis and corrosion. And these courses are available to individuals, as well as we offer group discounts. And finally, if you have any questions, feel free to reach out by email or calling. Thanks for watching, and good luck with your metals. Bye.